Let's see. All right. So on 8.4, right, we're going to be talking about something called common logs and natural logs. Right? And so basically a common log is just a logarithm with a base of 10. Okay, so it always is in base 10. Where a natural log is a logarithm with a base of e. Now some people are like, what? Okay, now this e is not a variable, right? The e is actually, you know how pi has kind of a representation of what it is? E is that same kind of number, but it is like 2.718281, blah, 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 blah. Okay, so it just keeps going and going and going. So we usually say E is approximately 2.72. But on the stuff that you'll be doing today, we're not going to use this, 2.72 all that often. We're going to be using this E. So I want everybody to look at your calculator right now, and let's find where E is. So if you can find, so there's a button that says, a lot of times people think it looks like it says IN. That's actually a lowercase l, and this is LN, which stands for natural log, okay, which is this. Right? Usually on the shift of that button, right, so there's this, and then the shift on it is that e to the x power, or something like that. Does everybody see that? And if you put into your calculator, again, you're going to have to play around with your calculator a little bit, because on some calculators, to use this this e to the x there, right, you would go shift, right, and then you'll press that LN button, which gives you that e to the x, right, and then you would put in, it will give you, in the screen, it'll say like e to the box or something like that. And if you just put in e to the first power, then you're going to get something that says that 2.718281, blah, 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 blah. Right? However, on some of yours, you're going to have to go the other way. You're going to have to put the 1 in first, right? So it wants the power, and then you'll click on that e to the x button. And then you'll get the 2.718281, blah, 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 blah. Okay? Okay, so is everybody able to figure out how to use that E button? Find it and come up with that 2.71. Let me know, because if you're having a struggle with it, somebody else in the class I'm sure is too. So make sure you know how to do that. Okay, so that's the natural log, right? So the common log button, right, is just the LOG button. But the natural log button is that LN button, right? So knowing which one they want you to use. And remember, you're going to get different answers because one has a base of 10, one has a base of E, which is, close to 3, but not quite 3, right? So it has a different base. And the reason why we have natural logs is because there are things in nature that tend to grow and decay at this very mystical amount, that this E. And so that's why they've kind of used this E. Like, so when things in nature are growing, like bacteria or something like that, or something is decaying, like a dead animal on the side of the road or whatever. Right? So these are, usually things found in nature. And so you might see this E come up in like a biology class or something like that, too, when you're talking about growth and decay. All right, so try on your calculator. Well, actually, on this first one, I want you to try to not use your calculator first, and then we'll look at it and see if you need to. Okay, so if I wanted you to find the natural log of E to the -4th power. But one thing that you need to understand that is not written in here is when you have natural log, they don't show you what the base is because they assume you know that the base is E. Right? Natural log always has to have the base of E. So let's go back up to our properties that we wrote down. Okay, and remember how I said when the base of the log is the same as that number, right? When those two are the same, right? You get 1 if you have the base, the log to an exponent, then your answer is that exponent. Right? So if you look at this, right, we still have the same kind of thing going on here, where that the base of E and then e to the 4th power, they're kind of like undoing each other. Okay? And so then you're just left with -4. So try it on your calculator. See if you can figure out how to put that in. This one's probably harder to put in than it is just to see this property here, but sometimes people want to know. Right? So you don't have to put base E in, it's assumed. So you just hit the natural log button, right? And then e to the -4th power, right? So then you'll want to do however your calculator does it, but you got to hit e to the -4th power, and then when you press equals, you should come out with -4. Is that what you guys are coming out with there? Do you see how that is the case? Because if we tried to do the natural log base E of E, right, this is just 1. And that's why this is kind of like, a lot of people think, oh, okay, that's kind of like goes away, and we're just left with whatever the exponent is there. Okay, it's kind of a way you can think of it.
I you could push the LN and the E button, because I thought they were kind of similar.
Yeah. Did you figure it out or no?
Yeah, I figured it out.
Okay, cool. Yeah, you just have to hit usually the second, right? That shift button, the second, and then the LN, and it'll give you that E to the X. On most calculators, those are the ones that are together. Okay, awesome. Okay, let's try a couple more here and see what you think. So what about this next one? What if I had, asked you to find E raised to the natural log of 7 power? And this is a property that we didn't really talk about yet, but it's similar to this. If we have E raised to the natural log of E natural log of E, that is also 1. And so then we're really just left with that 7. So 7 would be our answer on that. Okay, so it's kind of cool the way these, work out, but it's just understanding these properties of logs with it. Right? What about this one? How about if I have E to the natural log, the square root of 3? I would not suggest trying to put this in on your calculator. Right? There's no need to. What would the answer to that be?
Square root of 3?
Yep, square root of 3.
Did you hear the confidence in my voice just now?
The little question, but you should have been very confident, right? Because that goes away. You're just left with that square root 3. So sometimes you'll have answers like that on your homework, and that's perfectly fine. Okay, let's do one more. Let's look at one like this. What if I have the natural log of 1 over e to the 6th power? Okay, well that's kind of weird because we haven't dealt with one like this before, right? Where there's a fraction. So I would say it might be easiest just to flip that e to the 6th power upstairs, right? Remember with properties of exponents, we can flip it upstairs, but that's going to make it e to the negative 6th power, right? And so then what would my answer end up being on this? Okay, good. So you're saying negative 6, right? All right, so that's kind of what we're doing on these type. And then let's just do a couple more with the calculator just to make sure that you're good with it. And then we'll take a little break. Okay, so everybody try and do the natural log of 4,568. And I want you to round these to 4 decimal places. And I want to stress to watch for these instructions on the final exam, right? There are some of you that missed things on the last exam because you didn't, like round to the decimal place that they were asking for. I didn't make the whole thing marked wrong on your exam, but you didn't get all of the points either, right, if you didn't round it correctly. So I gave you some of them back, but still, right, that's, I just don't want you to miss little points on something like that. Okay, and then after that one, let's do the log of 4,568. Okay, so what's the answer to the first one? Rounded to 4 decimal places. Just write it in on your chat. Do you come up with the answer? It feels like there's only 3 people here today because only a few of you are answering. Let me know you're alive by entering something into the chat box, please, right? So round it to 4 decimal places, right? All right, so we're getting 8.4268, right? The number after that is 3, so that's not big enough to round it up. So that's going to stay as an 8 there, right? But then when you do the log of that same number, right, and the whole reason why I chose the same number is because I wanted you to see that you get a different answer, right? And so you guys are saying you came up with 3.6, okay, but make sure you're rounding it to the place value that I'm asking you to, okay? I want you to try and practice that, right, so that you don't miss it on the test, right? Okay, so that's just knowing how to use your calculator, basically, on those, okay? So your answer on this would be 1/3, or if it was rounded to 4 decimal places, right, it'd just be this. Are you guys able to figure out how to put that into your calculator?
Can we go over it?
I mean, it's going to be kind of different with each calculator, but make sure you're hitting, so you want to hit the log button first, right? And then on a lot of your calculators, you'll have like a little button that looks like the x root of something. Right? So in some calculators, you either have to put whatever that root is, right, either before or after it. Oftentimes you have to put it before, though. So I'd want to put in, after my log, I'd put in my 3. Right? So click on the 3. Then that button, which is actually a shift one, right, that you'd have to do. So you have to hit that shift button to get to this. And then put in 10. And then, depending on your calculator, like if it shows you on the screen what it has, you're going to have to like hit your little right arrow or something so that you can close your parentheses, because you have to put that cubed root of 10, and it has it kind of inside parentheses there. All right, so you might have to hit that arrow button, but then hit equals. Okay. How many by raise of hands were able to come up with that 0.33333333 on that one? Let's see, just so I can see kind of where you guys are at. Okay, and if you feel like you need a little bit of help with your calculator, I'm happy to stay, you know, like after class and give you like some one-on-one help with your calculator. Just because, like I said, everybody's calculator is going to be a little bit different. So that's going to be it. So, all right. Okay, well, let's look at, so there's just one more thing that I wanted to cover on 8.4, and it's called change of base. So sometimes you're going to be given the log of some base that's different than base 10 of a number. Okay? And so to figure out, like in order to figure this out on your calculator, because if you don't have that different base besides base 10, what you'll do is you'll do log of m, right? So log of the big number divided by log of b. Okay. Yep. So that's all you have to do on these to get that change of base. So let's do an example so you guys can practice it on your calculator. And again, let's round your answers to 4 decimal places. Okay, on here. So if you are asked to find log base 5 of 8. So to do this, right, you'll do the log of 8. And then again, on some of your calculators, you might have to do log of 8, press equals, right? And then do divided by log of 5 and press equals again. Okay, so let's see what you come up with, and let's make sure you know how to get to the answer here, because that's going to be approximately 1.2920. Okay, look and see if that's what you came up with. And if it asks for 4 decimal places, put that last one as a 0, if that's what it is. Because if you just put it at 292, it might mark you wrong because that's only 3 decimal places out. Okay. Okay, so how many by raise of hands came up with that? You're able to figure out how to do that? Got the 1.920. Okay, awesome. It looks like most of you are getting that, right? Another thing that I want to show you, so let's do one more here. So if we did log base 4 of 31, right? Now you could do the common log, right? So log of 31 divided by log of 4. But could you do the natural log of 31 divided by the natural log of 4? Right? So I want you to try both of those out and see, do you get the same answer or not? Okay, so type in your answer, what you got for log of 31 divided by log of 4. Just now to 4 decimal places. Remember, that's where we're rounding to, is 4 decimal places. Okay, type that into your chat. And then 3, 2, 1, hit enter. That's what you guys have. Okay, so most of you are saying 2.4771. Right? So what about with the natural log? If we do natural log of 31 divided by natural log of 4, do you get that? Yeah, you should get the same thing. And the reason why is because, you know, as long as we're dealing with the same base, on this first one, this is natural, or this is the common log, so they're both in base 10, right? And then on the natural log, they're both in base E. So it actually doesn't matter which one we put in, you are going to get the same answer for it, okay? But, you know, but be careful with that, because then sometimes people think, oh, well, if I do the natural log of a number, right, I would get the same thing as the common log of that number. And that is not true, right? You can only, you know, do that when we're doing this change of base stuff, okay? All right, well, let's go to 8.5 now, because 8.5 I want to make sure that we spend enough time on, because now we're going to be talking about solving exponential and log equation. Okay, and so again, you're going to want to remember, you know, how to change an exponential to a log and a log to an exponential, because that's going to come up a lot in using this 8.5. Okay. All right, but there's one other property we haven't talked about yet that I want to talk about. If we have a to the m power equals a to the n power, right? So these guys have the same base, and then we have the exponents there. Well, it just follows to be true, right? So if we have this, then m must equal n, right? Those exponents must be the same. They have to be the same if the bases are the same in order for these guys to be equal. Okay, so we're going to be using this, and this is called, so you'll see it says, oh gosh, what did I just lost the, oh my goodness, what am I trying to say now? brain just went blank. It'll come back to me in a minute. Okay, so let's try an example with this. And so if we did this example, we're trying to solve four to the 3x power equals 16. Okay, so what we want to do is get these bases so that they're the same. If we can get them the same, then we can just set the exponents equal to each other and solve it from there. Right? So I'm thinking, okay, how could I change the look of 16 so that it matches this base over here? Right? So 4 to the 3x power. And then I'm trying to get these bases to be the same, so I want 4 to the something power. What would that something be? Yeah, 4 to the second. Okay, now that my bases are the same, I'm just going to set the exponents equal to each other. So it's just like I get rid of those 4's. I don't need to do anything with it. So I get 3x equals 2. And then I'll divide by 3. So x equals 2/3. And that would be my answer. Okay. And you could check this, right? You can always do a check whenever there's a solve. So if I did 4 to the 3 times 2/3, right, so it's kind of like a 3/1 power, does that equal 16? Well, my 3's cancel out there, and I'm just left with 4 squared equals 16. So 16 does equal 16. So this does check out to be a good answer. Okay, so remember, whenever you're asked to solve, you can always check to make sure that you did it right, or just check and see if there's any extraneous solutions that we can't use. Okay. All right, let's try another one. What about one like this? How about if I have, again, I want to solve 4 to the 2x minus 4 power equals 8 to the 2x minus 3 power. Okay, so again, I need to get my bases to be the same. But if I'm thinking about this, right, on this one I'm going to have to actually change both bases because there's nothing. So if I'm thinking of 8, if I'm thinking of 4 to the what power gives me 8, right, that's not going to be a whole number, right, because 4 to the first power is 4, 4 to the second power is 16, right? I mean, you could put in a fraction there, but most people are like, I'd rather not deal with that, okay? So what we want to do is change these both to bases of 2. So I know 2 to the second power, right, is my 4, and 2 to the third power is my 8, right? So now my bases are the same, but then I can't forget about the exponents that were already there. Right? So now my bases are the same. Now I can put those exponents equal to each other. Right? And you could either distribute it through before or after. I'm just going to do it after just to make sure everybody is with me. And see, I'm just taking the exponents and bringing them down so I can solve for x because my bases were the same. So I can do that. All right, now let's distribute. So 4x minus 8 equals 6x minus 9. So let's get our x's on one side, right, and get our whole numbers on the other side. So I get negative 2x equals negative 1. So x equals 1/2. Or if you write it as 0.5, that is fine as well. Okay, what questions can I answer about that? Because sometimes that's kind of tricky here with this. Okay, how do I know what I'm doing with those things? Is that making sense?
So we just know to change the base.
You have to make, yeah.
To 2 because you knew that 2 times 2 is 4.
Yeah, and sometimes when the numbers get trickier, what I tell students to do is just make a little factor tree. So 4 is 2 times 2, 8, right, is 2 times 4, and then I can see, okay, yeah, that's 2 to the second power, this is 2 to the third power. So, and you can always do that with these, because like I said, when those numbers get bigger or kind of trickier, like, what, how can I do this, right? So if you do a factor tree, that's going to help you figure out what you need to have.
Okay, yeah, that's helpful, because I was just thinking, I mean, that one was easy, but I'm not
Yeah,
know all of them.
exactly. Yeah, so try doing those factor trees if you can't, see what that might be, because that can get tricky with bigger numbers. Okay, let's look at another one. Okay, again, we're solving. And I could have checked this answer. I didn't on this, but you could go back and check those and see that they come out to be the same. Awesome. It looks like David checked it out for us. Thank you, David. All right, so what about if we have 1/2 all raised to the x minus 8 power, right, equals 2 to the 7x minus 1 power. Okay, so are my bases the same?
Yes.
Are they exactly the same?
If you threw a -1 exponent on that 2, it would be.
Okay, yeah, so we need to do something to make them so they're the same. So you're saying it looks like it would be easier to change them both to be, the base of 2. So I'm going to leave this side the same. So 2 to the 7x minus 1 power. But then you're thinking, if I flipped this 2 upstairs, right, which I can do, that's going to give me 2 to the -1 power. Right? And that way, you can see, all right, now my bases are exactly the same, right? But I still have that x minus 8 out there that I can't forget about, right? And so I'm really going to be distributing a -1 through on this side. Okay, so go and take it from there and solve that one the rest of the way. See what you come up with. Okay, so this thing that we're doing here on all of these are these like bases property, right? Because we're trying to get those bases to be the same on these. Okay, so we got our bases both to be 2 there. When I distribute my -1 through, I get -x plus 8 equals 7x plus 1. All right, so I'm going to subtract my 7x over here and subtract my 8 to the right side. Right, and that will give me negative 8x equals negative 7. Did I do that right? Let's see, negative x plus 8.
It's 7x minus 1.
Oh, thank you. I was like, that doesn't... Glad you saw where that was at. I was like, something looks wrong here. There. And so that will give me negative 9, and then divide by negative 8. So x will be 9/8 for the answer. Okay. And some people are like, oh, that looks like a crazy one to try and check, but you could, you know, check it with your calculator if you're not sure. Okay. All right. Then something similar to this is the property when we have logarithms that are the same. Right? We call those like logs. Okay. So basically, if you have the log base b of something, right? And you have the log base b of something else, then really we would know that x equals y, right? So if we have log base b, then really all we're doing is setting the x and the y equal to each other to solve it. And just understanding that there's that property is kind of half the battle on some of these if you're like, I'm not sure exactly what to do. All right, so if you're given log base 3 of 2x minus 1 equals log base 3 of 3x plus 4, and they're not going to give you anything right now where those logs are different. Okay? In 1050, you'll talk a little bit more about that and what to do there. Okay, but for right now, we're going to leave that. And so now we can just, since we have the log with the same base, we're just going to put those insides equal to each other and solve it. So x equals negative 5. Right? And then again, you try and check that if you wanted to make sure. Although it'll be a little bit harder to check in that you'd have to do like a change of base since it's in log base 3 on those. But it's doable. You could do that. Yeah. All right, let's get to a few others, types of questions that you might come across that you also need to know how to work. Right? So how about if I have log base 2 of 8 minus 6x equals 5. Right, well, I'm looking at this, and if I'm kind of comparing it to ones that were above, it's like, okay, well, I don't have two logs, like, equal to each other, right? There's no log on this right-hand side of it, right? And I can't get, like, any, there's nothing with bases here. So we're going to go back to that original idea of changing the log form into exponential form. Okay, so let me put that down here as you're going to rewrite in exponential form. All right, remember that's going to be 2 raised to this power equals all of this. It's inside the parentheses. All right, so 2 to the 5th power equals 8 minus 6x. Right? There's no longer a log in it because we changed it to exponent form. Right? So go ahead and try and take it from here and solve that one for x. Okay? Type your answer into the chat, but don't hit enter quite yet. I'll have you try that and see what you get to. All right, let me see what you came up with. 3, 2, 1, hit enter. Okay, I'm seeing a lot of -4s. Let's double check it and see, right? 2 to the 5th power is 32. Let's subtract the 8 over. 24 equals -6x. Divide by -6. X is indeed -4. Okay. Now, I want to, you may have heard this, you can't take the log of a negative number. Okay, so meaning, let me show you something over here. So what if you just did, if you tried to do log of -5 in your calculator? What does it say there? Yeah, it says error. It's a domain error. Because -5 is not, included in part of that. Because we think about, I'm going to just kind of draw a really rough sketch of a log graph. Remember how it kind of went up like this and over? Right? Well, this is saying, like when x is -5. Well, -5 is over here, and our graph doesn't ever get over there, right? It's getting close, 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 right, to 0, but it's never going to get over to that -5. So that's why you can't take the log of a negative number, okay? But sometimes students hear that and think that, oh, this can't be a solution because x can't be -4. Well, look at when we do the check on this. Okay, what happens? So if I put -4 in here, so if I do log base 2 of 8 minus 6 times -4 equals 5, right? Look at what happens inside here. So I've got log base 2 of 8 plus 24. Right, so I'm really figuring out what's log base 2 of 32. And that I can do, right? That's what I'm doing on this. I can't take the log when I get, the log part by itself. That can't be negative. But if I come out with x equals a negative number, that doesn't necessarily mean that it doesn't work. Sometimes, in some cases, it won't work. So on these, you're going to want to check, right, these type, and make sure that you get that, because there could be some extraneous solutions and you come up with something, and then when you go and do the check, you're like, oh, if it came out to be negative, right, inside here, then we'd have to say it doesn't exist, right? Because that's really what's happening on this one. Log of a negative number doesn't exist. Okay. Questions on that? Are you following me? Following what I'm saying there? If not, speak up, please. All right. This one has just a lot of different types of questions in it, so let's look at a few more here. So how about if we have this? Three times 2 to the x power plus 21 equals 69. Okay, and again, it's telling you that we're going to solve it. We're trying to figure out what x is. Right now, x is that exponent. And so it's really hard to, solve for it when it's like this, and we've got all of this other stuff around it. So you got to think about, just with any kind of, equation when you're trying to isolate x, right? On this one, you're going to isolate e to the x, or sorry, 2 to the x power, right? So what would you want to start by doing on this one?
Subtracting n.
Yeah, right? I mean, think about if you just had like 4x plus 5 equals 7, right? You'd subtract the 5 over first and then divide by 4, right? You always take those same kind of steps. So same thing here. We're going to start by moving that 21 over. So I'll subtract the 21. And 69 minus 21 gives me 48. Right, then again, that 2 to the x isn't by itself yet, so let's divide both sides by 3. So 2 to the x power equals, well, 48 divided by 3 is 16. All right, now what could we do from here to solve for x?
Change of base.
Change of base, or you mean like bases?
Yeah, well, yeah. If
'Cause
you divide log 16 by log 2.
You would get that. So you'd really, I mean, I guess if you're thinking of that, it would be a little bit easier with the way we talked about to change this back into like log form or something like that, right? But on something like this where it's, pretty easy, we're thinking 2 to the what power is 16, right? And so 2 to the 4th power is 16, right? Or you just change that to 2 to the x equals 2 to the 4th. So x equals 4 on this, right? And again, you can check that, right? Making sure that when you put 4 in here, that you're doing your order of operations correctly. Again, on the last test, I noticed that some people missed some things because of order of operation stuff, forgetting that you have to do this exponent part first and then multiply by the 3, right? So I tried to do 3 times 2 and then raise that to the 4th power, but that's not what it says. Okay, so just watch that closely, right? But you can definitely, check these also to make sure that that's working out. Okay, let's look at one other one. I want you guys to try to do this one on your own and see where you get to. So let's try doing 19 e to the x power minus 16